An open delta service, also known as a V-phase or partially closed delta, is a type of three-phase electrical power system that uses only two transformers to provide three-phase power. Understanding the voltage characteristics is crucial for identifying the service type. In this specific scenario, the voltage measurements provide clear indicators of an open delta configuration. Phase A to ground reads 240 volts, phase B to ground reads 0 volts, and phase C to ground reads 240 volts. Furthermore, the phase-to-phase voltages are all 240 volts, that is, phase A to phase B, phase A to phase C, and phase B to phase C. The presence of a phase with 0 volts to ground is a key characteristic of an open delta system with a grounded center tap on one of the transformers. To fully grasp the open delta service, firstly consider its advantages, secondly its disadvantages, and thirdly common applications. Open delta services offer a cost-effective solution when the full capacity of a closed delta system is not required. Only using two transformers reduces the initial investment and makes it suitable for smaller loads or temporary power needs. However, an open delta system has a reduced capacity compared to a closed delta system. It can only deliver approximately 57.7%, or the square root of 3 divided by 3, of the capacity of a similarly sized closed delta bank. This limitation makes it less suitable for applications requiring high power demands. Open delta configurations are commonly found in rural areas, small commercial buildings, or for supplying backup power. They are often used where the load demand is relatively low and the cost savings of using two transformers outweigh the capacity limitations. The voltage measurements are critical for identifying an open delta service. In a typical three-phase system, the phase-to-ground voltages should be balanced. However, in an open delta system with one phase grounded, one phase will have 0 volts to ground while the other two phases have equal voltages to ground. The phase-to-phase voltages will remain balanced. Analyzing the transformer connections is essential. An open delta service uses two transformers connected in a V configuration. Each transformer provides a portion of the three-phase power. The absence of the third transformer distinguishes it from a closed delta system. The grounded phase in an open delta system is typically achieved by grounding the center tap of one of the transformers. This creates a reference point for the system and ensures that the voltage to ground does not exceed the phase-to-phase voltage. The grounded phase, in this case phase B having 0 volts to ground, is a hallmark of this configuration. When troubleshooting an electrical system, voltage imbalances can indicate various issues, including an open delta configuration. If the voltage measurements show one phase with 0 volts to ground and the other two phases with equal voltages to ground, an open delta service is highly probable. It is important to verify the transformer connections to confirm the configuration. The capacity of an open delta system is limited by the size of the transformers used. The total apparent power that the system can deliver is the sum of the apparent power of each transformer. However, due to the V configuration, the actual power delivered is less than the sum of the transformer ratings. When planning an electrical installation, it is crucial to determine the load requirements and select the appropriate service type. If the load demand is expected to increase in the future, a closed delta system or other three-phase configuration may be more suitable than an open delta system. Open delta systems can be upgraded to closed delta systems by adding a third transformer. This increases the capacity of the system and provides a more balanced three-phase power supply. However, the cost of adding a third transformer should be weighed against the benefits of increased capacity. When working with electrical systems, safety is paramount. Always de-energize the system before performing any work. Use appropriate personal protective equipment, including gloves, safety glasses, and insulated tools. Follow all applicable electrical codes and regulations. When measuring voltages, use a calibrated voltmeter and ensure that the meter is set to the correct voltage range. Verify the voltage readings with a second meter to ensure accuracy. If any abnormalities are detected, investigate the cause before proceeding. Open delta systems can be used to supply both three-phase and single-phase loads. The three-phase power is available from the three terminals of the delta configuration, while single-phase power can be obtained from any two terminals. The single-phase voltage will be equal to the phase-to-phase voltage. When connecting single-phase loads to an open delta system, it is important to balance the loads across the three phases as much as possible. This helps to minimize voltage imbalances and ensure that the system operates efficiently. Open delta systems are often used in temporary power applications such as construction sites or outdoor events. They provide a convenient way to supply three-phase power without the need for a permanent three-transformer installation. In these applications, the open delta system is typically connected to a portable generator or other temporary power source. The grounding of an open delta system is crucial for safety and proper operation. The grounded phase provides a return path for fault currents and helps to prevent voltage surges. The grounding electrode should be properly sized and installed according to the applicable electrical codes. Open delta systems can be used in conjunction with other types of electrical services such as single-phase or closed delta systems. In these cases, it is important to ensure that the different systems are properly isolated and that there is no potential for cross-contamination. Open delta systems are relatively simple to install and maintain. However, it is important to have a thorough understanding of the system's operation and limitations. Proper training and experience are essential for working with open delta systems safely and effectively. The voltage measurements in an open delta system can be affected by various factors such as load imbalances, transformer impedance, and voltage drops in the wiring. It is important to consider these factors when troubleshooting voltage problems. Open delta systems can be used to provide power to a variety of equipment, including motors, pumps, compressors, and lighting systems. The specific equipment that can be powered by an open delta system will depend on the voltage and current requirements of the equipment. Open delta systems are often used in industrial applications where three-phase power is required for certain processes but the overall load demand is relatively low. In these applications, the open delta system can provide a cost-effective solution for supplying three-phase power. The efficiency of an open delta system is typically lower than that of a closed delta system. This is due to the fact that the two transformers in an open delta system are not fully loaded. The losses in the transformers can reduce the overall efficiency of the system. Open delta systems can be used in renewable energy applications, such as solar or wind power. In these applications, the open delta system can be used to convert the DC power from the renewable energy source into three-phase AC power. The power factor of an open delta system can be affected by load imbalances and the type of loads connected to the system. It is important to monitor the power factor and take corrective action if necessary. Open delta systems can be used in backup power applications such as emergency generators. In these applications, the open delta system can provide a reliable source of three-phase power in the event of a power outage. The impedance of an open delta system is typically higher than that of a closed delta system. This can affect the voltage regulation of the system and make it more susceptible to voltage dips and surges. Open delta systems can be used in remote locations where access to the power grid is limited. In these applications, the open delta system can provide a cost-effective solution for supplying three-phase power. The maintenance requirements for an open delta system are similar to those for other types of electrical systems. Regular inspections and testing are essential to ensure that the system is operating properly and safely. Open delta systems can be used in marine applications such as ships and offshore platforms. In these applications, the open delta system can provide a reliable source of three-phase power for various equipment. The grounding of an open delta system in a marine environment is particularly important due to the potential for corrosion and electrical shock. Open delta systems can be used in mining applications, such as underground mines and surface mines. In these applications, the open delta system can provide a reliable source of three-phase power for various equipment. The safety requirements for open delta systems in mining applications are particularly stringent due to the hazardous environment. Open delta systems can be used in data centers to provide power to servers and other equipment. In these applications, the Open Delta system must be highly reliable and provide a stable voltage supply. Open Delta systems can be used in hospitals to provide power to critical equipment, such as life support systems and operating room equipment. In these applications, the Open Delta system must be highly reliable and provide a stable voltage supply. The voltage measurements in an Open Delta system can be used to diagnose various problems such as transformer failures, wiring faults, and load imbalances. By carefully analyzing the voltage readings, it is possible to identify the cause of the problem and take corrective action. Open Delta systems can be used in conjunction with automatic transfer switches to provide seamless power transfer in the event of power outage. The automatic transfer switch will automatically switch the load from the utility power to the backup power source, such as a generator, in the event of a power outage. Open Delta systems can be used in conjunction with uninterruptible power supplies, or UPS, to provide continuous power to critical equipment in the event of a power outage. The UPS will provide power to the load during the brief interruption that occurs when the power is switched from the utility power to the backup power source. Open Delta systems can be used in conjunction with surge protection devices to protect sensitive equipment from voltage surges. The surge protection devices will divert the surge current away from the equipment and prevent damage. Open Delta systems can be used in conjunction with harmonic filters to reduce the harmonic distortion in the electrical system. Harmonic distortion can cause various problems such as overheating of equipment and interference with electronic devices. Open Delta systems can be used in conjunction with power factor correction capacitors to improve the power factor of the electrical system. Improving the power factor can reduce the current drawn from the utility and improve the efficiency of the system. Open Delta systems can be used in conjunction with energy management systems to monitor and control the energy consumption of the electrical system. The energy management system can provide data on energy usage, identify areas where energy can be saved, and automatically control equipment to reduce energy consumption. Open Delta systems can be used in conjunction with remote monitoring systems to monitor the performance of the electrical system from a remote location. The remote monitoring system can provide data on voltage, current, power, and other parameters, and can alert personnel to any problems that may occur. Open Delta systems can be used in conjunction with predictive maintenance systems to predict when equipment failures are likely to occur. The predictive maintenance system can analyze data on equipment performance and identify patterns that indicate an impending failure. The specific applications of Open Delta systems will depend on the specific requirements of the electrical system and the needs of the user. By understanding the characteristics and limitations of Open Delta systems, it is possible to select the appropriate service type for a given application. When working with Open Delta systems, it is important to follow all applicable electrical codes and regulations and to use appropriate safety precautions. Proper training and experience are essential for working with Open Delta systems safely and effectively. The data provided indicates the characteristics of an Open Delta service configuration, where understanding these characteristics is pivotal for ensuring proper system operation, safety, and troubleshooting.